This is a pretty famous volume, okay? What you've got is, you could call it a double quarter pipe, much like the double quarter pounder, which is not actually a half pounder, it's a double quarter pounder, really important. What you've got is, here, you've got a quarter of a cylindrical pipe, an identical quarter of a cylindrical pipe, and they're coming together and they're meeting at right angles, okay? And a particular volume we're interested in, I haven't drawn yet, so that we can draw it together. And you will see, by the way, I've talked a lot about this, the colors in your diagram, or the colors you have access to, they're hugely valuable, like they really, really help, okay? So I'm gonna do my best. You can see they're going to meet together at this kind of funny join, because I'm not going to draw them in because it would crowd my diagram too much. But each one of these here is kind of a quadrant of a quarter of a circumference, right? So you've got this arc coming all the way along, you get the same arc coming all the way along, and they're going to meet together at another arc that has the same kind of shape, okay? So you've got that guy there. It's kind of, I've sort of exaggerated how much it bends over just so you can see the curvature of it. Okay. Now, what about the rest of it? Well, the place where they're going to join together, if you can think about this quadrant here, and if it went all the way to the end of the pipe, okay, to this corner here, or rather that face, you're going to have this profile, this cross section, is going to appear on the back, right, over here. So it's going to have this kind of shape, like so. So think of that as the continuation of this face that's curved on the edge here, right? In exactly the same way, when I look from this side, you're going to get this cross section is going to continue, and eventually land on the back of that flat face there. So you're getting that shape, okay? So now we're almost there. We almost have the volume that we want. If I connect, there we go, these here, this is actually a volume. This is it, right? This part where the two quarter pipes intersect, where they overlap as it were, it's this weird awkward kind of shape in the middle, okay? This is the volume that I'm after. And that's kind of, in fact, all that you get as a setup, right? Now we need to add a bit of extra information on here to try and work out what's going on. The only constant they've given us is that the radius of the quarter pipes is A, okay? I don't know why they didn't call it R, but anyway. From here, to sort of see this a little clearer, what we want is another diagram. So, wrong color. What I'm going to do is I want to take just that part of it, just the actual volume itself, pull it out over here, and then I can start to think about what cross sections are going to be useful to me, okay? So, let's replicate this diagram, just this volume part here, and I'm going to help you by saying, start from this vertical axis, right, like so. I'll do it here because I'm going to need 3 diagrams in fact. Start from there. Do all of the straight parts first. So you can see I've got this base here, which is going to be critically important to us. So it's sort of going off at this angle, this angle, this angle, this angle. There you go. Okay, so these are all the straight bits, and all that's left is to connect the dots. So this guy, that guy, that guy. Okay, do you see the shape? Okay, now once you have this in place, you say, okay, I want a part of this. I want to work out what things do I need to add together in order to get this volume, okay? Now, when you think about getting cross sections, often the question will help you out and tell you what cross section to take. But before I show you what the question is for you, where do you think you would go? Where could you, or what axis could you slice so that you would get not the same cross section every time, because that would be a prism, but a similar cross-section every time. Any suggestions? You want to go, so I could go flat, so view this kind of like as a stack of vertical slices. So I'm going to go with that suggestion. One of the reasons you can know that is if you try out, and keep your perspective here, if I draw, for example, a parallel line here, so I'm parallel to these edges on the bottom, parallel line here, parallel line here. Okay, you're saying, oh yeah, I have this same quadrilateral, whereas if you try and do it any other way, you're getting these weird curves that you have to negotiate. So what's happening is, this shape is getting, and I could do one more up here, I think. These shapes are getting progressively smaller as you go up, but importantly, they are all similar to each other. Okay, so this is the actual slice I'm going to take. Here's my shape. Okay. So in order to think about this, right, you can see I've got a whole bunch of these. Maybe I'll show this one too, so you can see that guy. what is varying? What is the thickness of this thing as I move up and get different slices, okay? Well, you can see it's not this x-axis, which I guess would see is horizontal, or this y-axis going off in this direction. It's another axis altogether. I guess you could call it z, if you want. But being that I've oriented it vertically, it's kind of like part of the height of this shape. So the question itself actually takes that and says, okay, I'm going to say this distance here, I'm going to call that h. And I'm going to let h be my variable, okay? So if that distance there is h, then I can define the thickness of this cross-section as delta h. That's what's changing. Okay, so I've already made a huge amount of progress to understanding this question, but there's one last piece left. To work out the volume, of course, you've got to work out what each of these slices is equal to. Now, this is actually going to be, remembering that you started from like quadrants and all these kinds of things that are equal. Because this is A, this is also A. You agree with that? Which means that this is also A. But because these are the same kind of quarter pipe coming together, this is also A, right? So what kind of shape do we have there on the base? It's a square, okay? So that's really nice for me because all I need is the side length of this square and then I'll be able to work out the area from there, okay? So I need a few extra labels here to help me because I need to draw one last diagram and be able to work out what is the side length of this square. Like how do I sift it out from here, okay? So what I'm gonna do is firstly, excuse me, I'm gonna call that point there, well it's where all of the axes meet, so a natural name for it would be O for the origin. And then I'm just going to name this square, let's just call it ABCD. Okay, that's a pretty standard name. A, B, C,